So Daniele, could you share the slides?
Yes. Can you see them?
Yes.
But it seems okay. And my audio is okay?
That's good. Yeah. But I didn't. Okay. I don't see Oscar. Oscar is in the meeting room or not? I think he attended the meeting physically,
Oscar's
right?
here.
Oh, he's in the meeting
I'm here.
room. Okay.
I'm here.
Oh, good. Yeah. So I also see our AD John. He's in the meeting. He's online. So I think maybe we can start, Daniele.
Good morning. Yeah, sure. Please.
Okay, great. So good morning, good afternoon, good evening. Welcome to CCAMP session. So let's start. Please, next. Next page. Okay, so as usually, let's start from the loadware. I think we are all familiar with the loadware, which is about the IETF policy and the process that we have to agree to follow. So, and you can also look at the documents, BCP documents, to get more information if you are not familiar with this kind of rules. And next. And there are some, conduct guidelines. And I think this is a kind of, supplement to noteware. And more details, are described in BCP 54. And there are some key informations in summary. It says we should extend respect and courtesy to our colleagues at all time. And we also should have impersonal discussions, rather than personal stuff like no personal attack, right? And then next. Next up, please. It seems delay.
Yeah, probably there is a little bit of delay.
Okay. Tips, yeah. I think this time we have many participants participating in this meeting physically, and that's good. But we still have more people, online. So for in-person participants, please make sure to sign in the session by the Meet Echo, and use the Meet Echo to join the my queue. And please, if you are not going to using the on-site version, please keep the audio and the video off. And also, the last year, COVID-19 is still there. So wearing mask is still recommended. I just say eternal does not wear a mask, right? So, but anyway, for the sake of the human beings, it's better to take the mask. Okay, for the remote participants, I think we also should make sure our video and audio off, unless you are speaking or or chairing during the session. And also, it's recommended to use a kind of headset, and to avoid any echoes. Next. No changes. The delay, it seems, is quite much. Okay, for the administrative, actually, we can get the.
Okay. No, but I was saying you can download a copy of the slides on your PC, and I will turn them for the rest of the team.
Okay, sounds a good idea. Okay. let's look at the administrative. So we can say we are using the Meet Echo, and I think we all know how to use the Meet Echo. And you can also get some information about Meet Echo from the link, and there are some pictures to show how to use the key functions of the Meet Echo. Next. And then for the note takers, yeah, I think we all can capture some things of the discussion through the online tool. So please help the chairs to capture something of the discussion. That will be much appreciated. Blueshies, actually no additional actions for the Blueshies. And we can also, download materials from the link and use the Zulip, for chat something, or I think we can also just use the Meet Echo chat panel, and we can see if there are some comments from online, and then go to the page of the session. So this time we have 2 hours session, only one session. And please move to the agenda. So this time we have 9 drafts to be presented, and 6 working group drafts and 3 individual drafts. So I think it's still a busy agenda for us. And there's a reminder for the mailing list. I think it's always always we encourage the working group to use the mailing list as much as possible, and especially to be more active on the list, since we know that we can discuss anything in the scope of the CCAMP, like open issues, introduce some new drafts or new ideas, especially potential new working group documents, because we know that working group consensus is determined on the main list. Next. And then go to the, another reminder on the IPR process. I think we are doing very well, actually. Yeah, I think we all know the IPR process stuff. So yeah, we can skip. Okay, it's up. It's for you, Daniele.
Great, thanks. Welcome also from my side. Let's go through the document status. So since last meeting, we have 2 drafts in the ISG processing. The OTN beyond 100 gigabit applicability document, which is in ISG evaluation, and the FlexiGrid Young model for which the publication has been requested. Today, as Fateh was anticipated, we have 6 working group documents in the agenda, so I won't spend much time to discuss about them because we will have a presentation from the authors. Just a quick recap on the ones that are not being presented. So let's start from the OTN, the layer 1 types and the OTN topology. Dan is the shepherd of these 2 documents. Thanks a lot for volunteering to do so. The drafts have passed the working group last call, and we are now on waiting on the write-up. If I'm not mistaken, we are now in the phase of addressing the last call comments, and then we are ready to move forward. An update also on the Flexi Young configuration model. Actually, there is no big update there since the adoption that we did in June. And actually, more work is ongoing both on the draft and the Young modules. Another draft on which we are working in these days is the L1 CSM. We recently concluded the IPR polling, and the routing directorate review is ongoing. Actually, we have two of them in parallel. Adrian, which had also provided on the mailing list a lot of comments before the last call, is doing the review. But we also asked for an external review. Nick from the MPLS working group has been selected. Path computation. These are two drafts moving in parallel: the optical path computation and the OTN path computation. They have both been adopted in October, and work is going on both of them without any particular issues. And then we have the other drafts which are, let me say, for which a little bit less of work has been spent in the last few months. The client signal Young model and the DWDM interface LMP. Some changes, but mostly keep alive ones, have been provided also in regarding the DWDM interface parameter Young model and the Ethernet client T topology Young model. So this is where we are. The tunnel modules, they are almost ready since a while, but they have the Young T draft in the T's working group, which is, let me say, a pre-requirement to move this to the last call and to the next steps. So this, as soon as the Young T model will be published, we will have the green light to progress these two documents as well. Liaisons and communications, we have actually two of them, one from the ETSI, ISG working group, and one from the ITUT study group 15. You have seen them because they have been sent to the CCAMP mailing list. So please, both of them are for action, if I'm not mistaken. We still have quite some time. The deadline for the first one is set to end of December, while the other one is in April. So no rush, but if you're interested in them, please have a look. And I think that's it for today. Let's. Is there any question, any agenda bashing you would like to propose? If not, we are ready to move to the first presentation. Sergio is presenting, if I'm not mistaken. Sergio?
Can you hear me? Ciao, Ita. Ciao, Daniele. Can you hear
Please.
me?
Okay. Yes, perfectly.
Okay. Hello, everybody. I'm going to present the update and the status of the Young data model for optical impairment aware topology. Next, please. Okay. With respect to the IETF115, we basically focused on the completion of the optical protection architecture. That was a big issue. And we provided both the part related to the, we progressed the text in the draft, adding a specific individual subsection with that was dealing with the three OTSI protection use cases. So the case in which OT and the OTSI protection function are integral part of the WDM TE node. The one in which the transponder and OTSI protection and rodent function are in two different WDM TA node. So we have the case in which we have the remote transponder, and the case in which the transponder plus the OTSI protection function are in a separate WDM TA node. So the case in which we have the protected remote transponder. We provide the extension for the optical capability reporting. And from the young point of view, and in the young, we also fix the augmentation of when statement from absolute to relative to provide the correct instance in the network topology list. Next, please. Okay, so we in the basically for the OPS protection, we have two steps. So the first steps in the version 10, in which we provide the representation of the OTSI already there in the network that was essential to calculate optical feasibility for the new OTSI. In this version, we added the OPS capability reporting, so the possibility to provide the knowledge of the capability to configure the OPS protection when we set up a WDM tunnel. Next. So, as I said in the second slide, we have three cases. The first case is with a single traffic engineering node. So all is integrated, both the transponder, the OPS protection function, and the rodent part. So we have single TA node, and we can consider the connectivity between the port of the transceiver, the two line ports of the degree. In this case, from model perspective, we can use the tunnel termination point and the local link connectivity lists construct. We do not model specific the add drop port block, but we take into account the other block in the context of optical impairment, as we will show after. And we already exploit an attribute related to the protection type under the tunnel termination point. Next. So we have two problems to solve. How to split the local link connectivity list that is as a key based on TP, termination point, so only one TP per entry. We need to have the split, so to point to the two different termination point. And so we augment the local link connectivity list with a specific list of additional line termination point, link termination point. Then, as said, we need to take into account the different paths used depending and the optical impairment implication in the usage of different drop ports. So the paths towards LTP belonging to the protection can be different depending on the drop ports that has been chosen. The solution is to add the new list in the new list of LTP to provide also the optical impairment related to the fact that you use one or the other drop port. For example, the optical impairment of the path related to the picture before between LTP2 using add drop port 2 in the picture. Next. This is the case, the second case, and that is transponder remote, and the OPS protection and the ROADM part is another WDM-TE nodes. So is the case of remote optical transponder. In this case, we use as the construct the Young construct. We use connectivity matrix. And we need to add a new attribute related to the protection type under the termination point. And the connectivity matrix is augmented to describe the potential connectivity to additional line link termination point, and the related optical impairment in case are not the same as the case of the working LTP. The third case is, as said, related to the integration in one WDM node of the transponder plus the OPS protection function, and then the ROADM part in another WDM-T nodes. In this case, there is no difference in the perspective of the Young model with respect to the first cases. So the protection configuration for the protected TTP can be described in the same way as for the use cases in the first case, so the integrated model. So all using a local link connectivity list. Next. Okay, so, this is the extract of the new tree related to the single node case integrated and the protected remote transponder case. So we added in the part of the local link connectivity list a specific new list of LTP with the related optical impairments in case we need to have also specific optical impairment. Next. Okay, this is the case of two WDM-T node case. So this is the extension. So we augment the connectivity matrix construct. So we added in the connectivity matrix the list of new LTP and specific ROADM, both in the from part of the connectivity matrix and in the two part of the connectivity matrix. And we also define a new protection type under the termination point to provide the knowledge that in this TP is possible to configure or OPS protection. Next, please. This is the extract of the Young part to see that, to show that in case of from the new list that we added in case of from, that is practically the case of the merging part of the protection. The list applies only when the two parts, so the point in which there is the merging for this connectivity matrix supports individual OTSI protection. So the protection is supported on the two LTP. And in parallel, in case of the two lists, the from LTP need to support the protection. Next. So for the open issue, we have a GitHub in which we track the issue, the discussion, resolution linked to the Young model. We solve from IETF 114 two issue, so 107 exactly for the optical protection switching, and the 79 that was closed and was related to the usage of the possible user instead of relative expat the usage of ancestor function, but at the end we decide that was clarified also with network, and the relative expat is still the chosen solution. We still have only five open issue, and okay, and this the last point is the address of the GitHub part. Among from this open issue, some discussion and also some progress have been already done, but the intention is to complete that in the context of this time frame for the next IETF. Next, please. Okay, next step is that we need to complete the part of the protection with also multiple the protection of the section, so the media channel group protection. We need to address the issue that are still remain, so that, as I said, is just 5. We consider to be ready for an early young doctor review, and okay, for everybody that can be interesting in this draft, we weekly meet on Tuesday at 2-3 from 2 to 3 p.m. European time. Okay, I'm finished. Any question? Hello?
I see Fatai is joining the queue.
So I have one comment for clarification. So I think there are lots of descriptions about optical protection in this draft. So regarding optical protection function, I think this should be a kind of general function for both W-SUN topology without impairment stuff and optical impairment aware topology. So if my understanding is correct, it seems that the optical protection model should also be applicable for W-SUN topology. So which means that after 1994 should be updated. So if my understanding is correct or not.
Okay, so I think that the protection, yes, it could be applicable also for the W-zone and flexible grid. The text, I don't know if you mentioned that there is no description, but now there is the description of the OPS in the drafts. And Yeah, the intention here is obviously to take into account of the optical impairments, but not in prevent to use that in case optical impairments is not considered.
Optical protection, it's a kind of a general function, and then we should think about how to, define the optical models in this, in which draft, Otherwise, if we say, so for example, the implementators, review the W-sound topology draft. Actually, there's no optical protection stuff in this draft, and then they have to look at the impairment draft, and then they can have full picture, right?
Okay, this is, I think it is a general case, not only for OPS protection, Fatai. I mean that it's a general case with respect optical impairment implication in the context of both flexible grid and W zone.
But the thing, sorry if I jump in, the thing is that probably we will find other items which are in common between WZone and optical impairments aware WDM. So one solution could be to have a dedicated document with things in common between the two of them. That could be an option. I would need to think a little bit what the best option would be, in my opinion, because I don't know by heart if this could risk to slow things down, etc. Probably Italo and Adrian already have an opinion on that, so let's hear what they say. Italo, please.
Yes, I think maybe up to now we focused on the information that we need to convey for optical impairments and more. And maybe what we need to do after this information is more stable is to understand what is strictly required for optical impairments, what can be used in other application, and maybe we can split. It's just a matter of moving stuff from one module to another module to have a more modular designer, a lot more modular designer, so we can have some pieces of this work that goes in other application where you don't need optical impairments, and we can leave it in the optical impairments, only the optical impairments stuff. Then we can try to look at that in details and see if we can split that. I don't see any major issue blocking this. We maybe just need to take a look at it in details.
Okay. Adrian? That one doesn't work.
Right, I'll do it from this one. Hi, I'm Adrian. I really only wanted to speak so that somebody who was physically present would join the meeting, but Italo got there first. You were talking about the protection stuff, and I'm concerned that for protection we do try to keep stuff general, and I wondered why the optical protection needs anything that isn't already in the general TE protection.
That's a good question. Sergio, would you like to try to answer?
One of the cases is one of the I said during the presentation. For example, you can need to take into account a different potential optical impairments depending of which drop port you use. So the protection is there, but if you are able to take aware the fact that optical impairments can be different, because that could happen. In the 90%, 95%, the path crossing different LTP can be the same, but you in this draft take into account the fact that it could also be different. So the concept of the protection is the same, but here what we need to take into account the fact that the impairments can be different. So this is not the concept that is changing.
Right. So you're effectively talking about filtering the available topology for protection to only those paths that meet the impairment constraints.
Exactly. Yeah.
Okay.
But if that's the case, then WSON doesn't need anything in addition to the TE, and only the optical impairments aware does. So in that case, all the protection stuff would fit perfectly into this document.
Yeah, that's a good question. Sergio, can you go to the tree? Maybe it's easier to see the point. Can you move the slides where we presented the tree, the young tree?
Yes.
Thank you. Yeah. Okay. Yeah. Okay. I think the additional LTP list is
no, it's not here. No, it's not there. It's not the tree here.
Yeah, I cannot read that far. Okay. Yes. Okay. Here. Yes. It's here. The additional LTP stuff is something which we may think about being generic, but I wonder whether there are other technologies where there is a difference, different reachability between the working path and the protection path. Because what we are addressing here is that the working port and the protection port can get into the ROADM on different add-drop ports and have different reachability than depending on whether you are on the working on the protection path, which looks very technology specific. And then in addition to that, we have the impairments, which are optical impairments. So these additional LTPs, we can discuss whether it is generic or only for WDM. And the impairments is definitely only for impairments.
Exactly. So actually, there are three different classes.
The first one is needed for WZone and FlexiGrid topology as well, if you don't have the impairments.
Actually, the thing that we would need to understand is what fits into generic enough to be T. What is generic for WDM, so that fits in WZone, and what is optical impairments specific that goes into this document. So these are the three different categories. Who do we have now in queue? Dan or Julian? Who was first? You forgot to enter the virtual queue, Dan. Yellow card for you. Julian, you go first. And then Dan.
Okay, thank you, Daniele. Hi, everyone. Julian Moric, Orange. The good news is that part of my command has already been addressed during the previous discussion. I wanted to add that the feature here is mainly about having 1+1 protection, which means that we have a secondary pass with an actual signal in the fiber, meaning that we need this info for any upcoming pass computations. So this is why, to me, it's a bit specific to optical impairments. WSON looking at maybe just the spectrum availability may not absolutely require that. So it could be an improvement, but it's not mandatory. So it's not that clear whether it should be included in more generic module or not. So I think Italo proposed a right path forward to have a deep dive into like trying to draw the line, but I think it's not that obvious that this is fully generic. There is some highly dependency on impairments there. My second point was that there are some previous situations where we have some draft extending an existing stuff where only some subpieces may be needed. I like to mention, for instance, the SRRG within the IGP. It was part of the GMPLS extension to the IGPs, and it's pretty obvious that anyone can implement SRRG extracting from a GMPLS draft without any GMPLS at large in a given network. So there are some background there. So I don't know if it's really some of the material inside this document could be used out of the impairment context for further applications. So whatever the working group chooses, we will follow. But I think it's not that clear that it really needs to be moved. So that's it for me. Thanks.
Dan, please.
Okay, Daniel King, thank you. There's a recurring theme across various IDs currently in CCAMP, and that is, do we generalize the document to include FlexiGrid and sort of fixed Lambda, so WSON, or do we split? And I'm seeing this in impairments, in the tunnel discussion, in the path computation. Just off the top of my head, there's at least 3 kind of areas of work. So I'm wondering if we need some kind of coordination. There is, of course, common authors in some cases for these documents, but I would imagine anyone attending CCAMP at the moment might not be aware actually that this is kind of a recurring theme. So how should we, as authors and kind of working group, communicate this? Maybe I guess a design team is unnecessary and overly complicated, and maybe would take time. But I think maybe during the IETF, some of the authors should get together, and maybe we can sort of draft an email and drop it to the list, just to kind of advise people that this discussion is occurring. Thanks.
That would be great. Thanks, Dan. So next in line, I see Italo, Dieter, Ayua. Then I closed the queue because we are running late. Italo, you okay?
Can you hear me?
Yes.
All right. Okay, I would like to respond to the comment that was made earlier, whether we are actually looking at the protection functionality that's already provided by the TE topology Yang model. And actually we did that. So this draft we're currently discussing is really focusing on providing optical impairments for the protection function, because we're augmenting the TE topology where we believe it's needed to provide the optical impairments that are associated with the different paths through the network element, and to support path computation that needs to know these optical impairments. So I'm a bit hesitant separating out this from the current draft. Thank you.
Okay.
Okay, so Iowa here. Just wanted to add to Dan's comments, and I agree with that we need to we need to coordinate both WSON FlexGrid and optical impairment to understand which parameters are common across all of them. Because in some of the scenarios, the user may not care about the performance of the optical impairment, but they need to know how to configure the transceivers, and also to be aware of the 3R regions, and also the protection capability, to understand the reachability and to perform the path computation without optical impairment. And also another comment is the groupings we define today in optical impairment. We may need to look further to maybe group those that are considered common into a separate grouping, so we can later to reuse them in other drafts.
Good point. Thank you. Time to run to the next presentation. Sergio, will it be you to present it? Who is the presenter for the next slot? Will it be Sergio or Italo? I have both of you as presenters.
Mute. Okay. Okay, I present the update of RFC 93 bis. Next. So
is the audio coming through clearly for people online? Because in the room, Sergio's audio is very choppy.
It wasn't very good. Can you try again, Sergio, please?
Hello? Can you hear me?
Try again, please.
Sounds good now.
No.
Okay, so from the last IETF, the major update of the RFC 1993 bis was that we changed the authors of the ID and the Young model, taking into account the old authors of the RFC 1993 plus the new one for the extension. We made a text update taking into account the feedback that was provided by IANA operation manager that suggested to update the section 5 of IANA, and we have exactly updated according to their suggestion. And we update the Young model, fixing some of the issue that was in the list. So adding new attributes for alignment with the 400 gigabit ZR specification. We changed the fraction digit for the frequency terahertz and gigahertz. We added units for a specific group, and then we need to shorten an attribute that was too long and provide problem during compilation. Next, please. So this is the 4 attributes that we added in the drafts that it was coming from the specification of ZR plus and ZR, and we in fact reference the specification of OIF 400 ZR 1.0. By the way, we have still a pending issue related to that. Here is attributes that is in transmission. We need to add in parallel also the receiver part, and this is one of the issues that we need to deal. Next, please. Okay, here is the other modification we made. We provide, we changing the fraction digit for the terahertz and gigahertz, moving to 9 for the frequency from the terahertz and to 6 on the gigahertz. We provide the units for the attribute max diff group delay, and we change the name of these nodes because the former one was polarization dependent or was too long in the compilation. Next, please. We track the open issue in the below indicated GitHub address. We closed 5 issues with respect to the last IETF 114. we still have 21st open issue. And from administrative point of view, we meet together on Tuesday. So when there is the need, we exploit the time dedicated to the optical impairments also to discuss some point that is related to the 1993, taking into account that in 1993 there are already grouping that are using the optical impairment that is in the 1993, so is common also for possible usage for the other for other drafts. Next, please. So for the next step, we need to complete the Appendix A, providing the changings from 1993. And obviously, we need to fix the remaining issue with the perspective to diminish the issue that are still open. Probably the draft will be impacted with some modification that are related to the work that is ongoing in the alignment integration with the respected W zone and flexible grid. And there is some attributes that is already there in 1993 bis, but that following the proposal that probably will be presented today, they are going to change exactly to take into account both W zone and flexible grid. So maybe 1993 sure will be impacted on this modification in the coming days. I'm finished.
Good.
And
Adrian.
Hi, thank you for this. Can you please spend some time with Yang doctors sorting out how you do Yang module versioning? There's a draft in NetNod or NetConf that's been around for quite a long time, talking about how to do versioning and introducing a revision tag. And I think we're going to need that so that implementations are able to clearly explain whether they're doing 1993 or the new work.
okay.
Thanks a lot. Let's now move to slot number 3.
One more comment.
Please, Fatai.
Okay, so thank you, Sergio. I have one minor comment. So regarding OIF 400ZR, so during the last few years, CCAMP usually didn't reference to OIF documents, but actually for myself, I'm open, to reference to OIF documents if necessary. So if we are going to reference to OIF document, I think authors should add the OIF documents explicitly in the reference section, because actually there's no this kind of reference.
Okay.
Yeah.
Good comment. Okay.
Next one, Ayo.
Hello. Yeah. So Iowa from FutureWay, presenting an update to the OTN slicing draft on behalf of all the co-authors. Next page. So what we did for the draft since the last meeting, there are two parts. On the text updates, we added some clarification of how we use the NRP in that we allow multiple OTN slices to be mapped to the same NRP. And in that case, all the resources associated with the single NRP can be shared across all the slices, and this is aligned with the network slice framework description. And also in this draft, we introduced a new model for OTN technology-specific slice, and we added some description to the draft as well. So on the Yang model end, like I said, we added a new model called IETF OTN slice, which is a technology-specific model that a user can specify with OTN technology-specific SLO, SLE. So we add some common SLO, SLE arguments based on the new generic IETF transport network slice defined also in this document, which augments the generic network slice service model from TIS. And then we resolved some open issues as well in this draft. Next page. Yeah, so this is the detail of what we have updated for the description and the picture in the draft. We show that on the left side we have multiple slices that are mapped to the same NRP, and then they are all created. The NRP topology are created off of a native OTN T topology received from the domain or the MDSC controller. Also, it's worth to point out that the use of NRP is not mandatory for OTN slicing because of the nature of OTN circuit switching. In that so we could directly use the OTN slice to partition the resources. So it's not really mandatory for NRP. And also, even if we use the NRP, it does not mean that the actual data plane will be programmed to reserve the resources, because we could just do a control plane reservation of resources without touching the data plane. Next page. So for the Yang models, so first we defined an SLO SLE augment for the IETF transport and network slice, in which we added a few common attributes, like we put in the red rectangle box. So this customized attributes for SLO SLE applies for the top level objects like network slices, connection group, and topology, and also for the sub-level objects like the connectivity constructs, and also the topology, which includes the nodes, the links, and LTPs. So we have also had some discussion to see if all the constructs defined in this transport and network slice model could be possibly merged with the IETF network slice Yang model, which at this point is also trying to put some to introduce some concept of topologies, but unfortunately we did not have much opportunity to discuss that before this meeting. So I think we could discuss again with the authors offline to figure out whether it's possible to merge these two models. I guess until then we will keep the model as is within this draft. When we sort out, then we can decide if we so if it can be merged, then we're going to take this transport network slice model off of this draft, and if not, then we can probably discuss whether we should split split this draft into two, with one containing just the transport network slice model. I think we touched that point also on the last meeting. I'll leave it open for at this point. Next page. Okay, so here's the technology specific slice model for OTN. So the only addition to this model is we introduced some attributes that are specific to OTN. For example, the ODU signal quality, which a user could use to specify its expected signal quality for when the slice is expressed in terms of ODUs. And also the number and the list of ODU containers that a slice customer is expecting. Okay, next page. So there are still a couple of open issues. One is how we can define technology-specific attributes, because as you know, this model is based off the network slice MBI YANG model, which defines SLO, SLE attributes as sort of like flat and opaque list. So basically what this could potentially cause a problem is it may introduce some interoperability issues because the attributes are opaque, and then we need some additional implementation agreements when it comes to the interoperability testing. And those opaque attributes may not be benefiting from the explicit YANG validation because we cannot use YANG to validate it. Also, there are some complex attribute structure. And in particular, in our case, the ODU container structure that cannot be expressed using the opaque list. So for now, like our model here for OTN slicing, choose to not use the opaque attributes, but instead define them explicitly in the model. So the question we have is whether there's any sort of guideline or thoughts around how we use or define attributes in an opaque way in YANG, because I know this is probably not just for network slicing, but also common for all other models, right? So this is one open point we are having today. I think we need some more discussion about how we can move forward with it. Yeah, so the next page. Okay, so the next open issue is about defining a network slice with a topology. So in our model for transport network slice, we introduced a top-level topology construct to perform what we call resource-based slicing. And basically, in our thoughts, the customer can define a slice as a topology, as a customized topology to start with. And then a connectivity construct in a slice could point to an underlay path that reference the customized topology. So on the other hand, the TEAS network slice MBI YANG, as of today, is also trying to add a reference to a customized topology, and it's just at the starting point of the discussion, but it looks like the T topology is intended to be used. So I think the main difference with that is whether we treat the topology as a customer's intent, or a something that a provider, a network slice provider, can expose to the customer to use, right? That's the first open point, and the second point is whether the T topology model itself is the right model for the network slicing MPI, because the T topology is designed to be not like an intent-oriented model, but it can be used as the model for network slice realization at the MPI of the controller. So that probably needs some additional discussion. And yeah, so finally, as I said, whether we consider merging the network transport network slice model with the network slice MBI in terms of defining the customized topology, that will be discussed offline. Next page, I think, yeah, the next step are continuing the discussion to address those open issues and to work with the network slice MBI authors to align the two models, and then to continue the refinement of the technology-specific SLO SOE for OTN. And also before the call, we had some good suggestions from some of the co-authors about adding a few examples for different types of OTN slices. I think we should do that, and perhaps even can include it in the draft. So we have usually we have a usual GitHub repo under the CCAMP working group, and we have the weekly call on Thursday, 10 to 11 Eastern time. So anyone interested in this work are more welcome to join the call. I think that's the last.
Thank you.
Okay, thank you. Any questions?
Regarding the open issues, I would suggest putting them together and sending them to the mailing list, potentially including also the TIS mailing list, to see, I mean, if we can move things forward a little bit.
Yes, I agree.
Okay, next one, Mr. King.
Hi, good morning, everyone. So Daniel King, just giving you a quick update on some of the FlexiGrid work. Know that we are behind schedule now, so I will try to make this as brief as possible. Next slide, please. So essentially, the FlexiGrid discussion is split into two documents, the topology and the tunnel. So with regards to the topology, the document is now stable. It has passed last call. We have had a routing area directorate review, so thank you, Dhruv. There are a couple of sort of minor editorial comments that need to be addressed, and we will post a new version of the document at some point this week. Next slide, please. You can see, of course, just as some of the other presenters have mentioned, we track open issues per CCAMP documents on the relevant GitHub. So as you can see, there's only a couple of issues that are open here currently. Thank you. Next slide. So this is the sort of the main sort of the meat of the discussion is occurring around the FlexiGrid tunnel, and this was kind of a recent change to the document. We renamed it from the media channel to the tunnel document, and we've now kind of transitioned from talking about the FlexiGrid topology to the FlexiGrid tunnel. Next slide, please. There are several sort of ongoing issues that we're attempting to address on our Thursday call. Actually, it's just before the OTN slicing call that I would just mentioned. I think the big kind of topic of discussion at the moment is regarding the merging or maintaining the separation of FlexiGrid and sort of generic or generalized WDM, as in fixed grid WDM. And I'll bring up this topic that I mentioned at the microphone. There will be sort of general descriptions for technology that will be recurring across the impairments, the path computation, as well as the tunnel documents, and then there will be technology specific. So what we need to do as authors is just try to get sort of consistency and style consensus, or at least commonality across all of these documents, because there's no point in also having to repeat the same discussion points on different calls. How we do that? Well, as I mentioned, several of the authors are co-authors of some of these documents, but not in every case. We should try to reach some level of consensus that we can propose something to the list, so other authors that maybe are not attending the calls or not aware of some of the ancillary work can easily just sort of show the format, the style that we're using. Next slide, please. So I had a couple of slides here with some Yang code, but I don't think we've got time to go through them. Just want to make a point that one of the use cases that we're looking at when we're developing the tunnel document is now the scenario where you'll have sort of mixed technology environments. So you may have a fixed grid WDM network, and you're looking to upgrade to some shiny new FlexiGrid technology. How likely is it that you will want a mixed media environment, maybe where you've got sort of fixed and flexible grid technology in the network at the same time? You might also have some sort of gray interfaces, and that's actually a new attribute that we've added, so a gray interface that we've added to our code as well. Now, I'm a bit sort of cynical about this, and I'm going to pick on Andy in a minute, and maybe one of the other operators, just seeing if he's paying attention, and say, well, how likely is it that you will have on one side of your network sort of fixed WDM equipment, and then on the other side of the network, you're going to have this kind of shiny FlexiGrid technology? Surely in an ideal world, you would just send a van out and upgrade or replace all of your equipment at the same time, turn it on and off, and everything just pops up and starts working. This discussion will have a significant impact on the amount of effort that we need to put into the development of the model. We've had a recent call where we had two operators, which had, both these operators had, two different opinions, so we will sort of request that other operators, and Andy, I'll pick up on this topic with you offline as well, just to get some kind of further input. Next slide, please. I can't remember what I was talking about next. Actually, I think the only thing I want to say here is that we also need to include parameters for 3R regeneration as well in the document, aka the model. Next slide. Yeah, I won't go through the code because we are slightly behind schedule. What I will do, though, is point to our GitHub again, where we have this presentation, and within the presentation, we've got some Yang code for you to look at. Actually, essentially, this is the code that will also be used for the path computation Yang model, the optical path computation. I should use plural here, Yang models, because we've got fixed and we've got sort of flexi technology models there as well. And then finally, we encourage additional people who not necessarily authors of the document to attend some of our calls. We do try to reflect, whether it's the OTN call or the path computation call, which we generally sort of do alongside the FlexiGrid tunnel call now, to reflect any kind of decision or consensus that we have at these sort of intermediate calls back onto the working group list as well. So we're not effectively making decisions that we don't allow the working group to kind of have some kind of input or informed decision as well. Cool. I think that's it. Are there any questions?
Gert. Gert, is a question for you then. Yeah.
Yeah. Can you hear me?
Yes,
Yep.
can hear you.
Okay, sorry. So I know it's you know, it's a popular distinction to be made between gray and colored interfaces, but in your scope, why is there any kind of difference? I mean, eventually, you know, photons come out of both. What is your consideration about this keeping them separate in, let's say, in kind of different implementation?
Yeah, I think essentially we just wanted one model where you would have sort of, you would be able to mark that an interface was a gray interface rather than a WDM or FlexiGrid. There aren't sort of a wealth of parameters that you would configure on that. You would just mark it as a gray interface.
Yeah, maybe just a, let's say, more a comment than any kind of, you know, suggestion. But if you think about CWDM interfaces, of course, WDM interfaces, or their interfaces like LR4, which have 4 wavelengths, which are fixed but still wavelengths.
Yes. Where do you stop? Yeah.
Right.
It is a Pandora's box, and I wasn't a fan of having one model that will apply to multiple technologies. I mean, we do tend to get encouraged by some of the chairs to kind of generalize the work. I suppose in this case, we just need to ask the users in the room, and of course the vendors, whether or not they see this model being used in a particular deployment for very specific technology. Right now it's gray interfaces, WDM, and FlexiGrid. But it's a good comment, and we will revisit it again on our call.
Thanks.
Thanks, Scott.
Thank you. Next presenter, Scott. Is it you, right?
Yes. Can you hear me all right?
Perfectly. Please.
Excellent. Well, this is a quick update on the Yang data model for microwave topology. And I'm glad to see that Italo is in the room so that in case I run into trouble, I can just fake a failure on and then make Italo do it. Anyway, this draft has been going on for a while. We have 3 Yang modules in the draft. I wanted to just quickly mention that I should have put this in the slides, but there is a topology, a microwave topology Yang module. There is also an augmentation that adds the bandwidth availability information. So we keep that encapsulated separately so that we can progress that in parallel with the microwave topology module. And then there's an augmentation that ties the microwave nodes to a IETF interface. So that's the basic structure of the modules that are included. Where we are is, since IETF115, we have changed the way we deal with this radio link mode, so that instead of just being an enumeration, it is a complex structure that allows you to specify the number of bonded carriers and the number of protecting carriers. And so we also modified the instance examples. One thing that we're finding to be very useful in validating that the Yang is fit for purpose is we create instance diagrams that show how to provision the radio information and put it into the topology so that we can run it through some automated tools like YangLint, for instance. So next slide. So our last issue that we're trying to resolve before we request a Yang doctor review and also a last call in the near future is this bandwidth utilization issue. So I'll put a little picture here. I'm not going to go into tremendous detail here. If you click on this, we're using the GitHub thing. So you can look at the issue and the discussion we've had behind the issue. But there are two formulas that we're trying to use to define bandwidth utilization. But of course, there are questions, as there always are, about how do you count the TX bytes that are coming out of the microwave link? How do you represent the time window that you want to use? And where is the calculation done? So those are the types of things. We have a couple of different ideas. One idea is to just stick the bandwidth utilization leaf in the model and make it a completely proprietary thing. Or if there's a desire, we could work on providing more details about how these things are done in different scenarios. So that's the last issue that we're trying to resolve. So if you go to the next slide. So the plan we have is to close on the bandwidth discussion. And then there is already an RFC 8561 that includes radio link module. And we have created an individual draft that modifies the radio link module. I just wanted to warn people about that because there are things that that are being used in the microwave topology module that could be extracted out and put into a common location. So that's what I mean by better encapsulation. So there are some things that that could be made more generalized and then stuck in a BIS of 8561. So we'd be interested in hearing people about that. I have a private GitHub set up for this. It's an individual draft, so we haven't requested any review of this from the working group yet. So that's something to look forward to in future meetings. And for those that, and something else I should have put here, I mean, I love watching these presentations because I see all the things I should have put in my presentation. For the microwave topology work, we do have weekly calls on Thursdays from 11 to 12 Central European time. So if you're interested, contact me or any one of the authors and we can provide you with the information on the WebEx. So that's I think all I had. Just a quick update. Thank you.
Thanks, Scott, also for the update on the new draft. Slot number 6, data model for network hardware inventory. Chaude, is that the right pronunciation? I see you are remote, so please enable the mic. Okay, great. But we can't hear you.
Oh,
now we can.
okay. Thank you, Chair. Hello, everyone. This is Chowder from Huawei. Okay, I'm glad to do this presentation on behalf of all the contributors. Our job is dealing with network hardware inventory management and provides a young data model which can be used in the northbound of network controller. Next slide, please. After last meeting, we have done these three parts of job. The first job, it will reveal the whole text of our document, and besides removing some obvious editorial errors and refresh some competent statement, we mainly focus on the following updates. Firstly, we added some description on to section 2.1.2 of this document and indicated that this document was used for inventory management of hardware resource and did not include state data. such as admins, state operational status, alarm, or performance or sensor data. This kind of data must be defined in the topology, alarm, or performance monitoring data model instead of our current model. Secondly, we update the description of section 2.1.3, which is used to introduce the attributes of network element. We state that the attributes of components defined in RFC 8348 are also applicable for network element object, but we didn't state clearly whether all the attributes uh, of all the attributes or component can be applicable to network element. Okay. Thirdly, we update the description of section 2.2, which is about the efficiency issues. This section contains a lot of discussion about the system's implementation, as well as the comparison of different models. So maybe some readers may not catch the final conclusion. So we indicate clear that the efficiency issue is for the retrieval of whole network inventory resource in large scale or network need to be solved at the RESTCON level rather than data model level. And fourthly, we mentioned the concept of generic data model in section 2.2 and stated that we intend to follow with the generic modeling idea of RC 8348. But we didn't give too much introduction of this. And this time we give more discussion. And in the discussion, we state that we'll use the generic component modeling idea from RFC 8348. And so the data model defined in our current document is called generic data model. Compared with the hierarchical data model, which defines the inventory object directly, our generic data model is more flexible and easier for background compatibility. And we don't need to break the model structure and make incompatible change like hierarchical data model, which when the new inventory object types are introduced. Okay, the second second jobs we did is review the issue list, which is record on our GitHub, and we close some of the issues which were aligned and or fixed with all the co-authors. The issues were fixed. The issues can be classified into three groups. Issues 32 and 21 are all related with the integration efficiency issue. And we close it because we consider that it is out of the scope of this document. And issues 19, 17, 14, issue 9, and issue 2 are related, is the relationship between our document with RFC 8348 and RFC 45. It is aligned that our data model will not augment RFC 8345 at the beginning of the when we present our draft in IETF for the reason of a big cluster or topology data and under the IETF network model, which is hard for filtering. And then we define a new route and we use the generic component modeling of idea of RFC 8348. And for issue 27 and 26, 12, and issue 4 is the discussion of our motivation and the concept inventory. This issue was raised at the beginning of feedback by the other working group. It is aligned that we propose to provide a generic data model for hardware management, which could be used, could be applicable to IP and optical and some other technology. And there is no overlap with the existing jobs in CCAMP and ops area or some other working groups. The third job we did is we compare our data model with OpenConfig platform to identify some more attribute which are missing in our data model. Next page, please. Okay, this is the table of comparison. Due to the space limitation, I divided the comparison table into two tables. And the first column of this table is the attribute defined by OpenConfig platform. And the second column is the corresponding attributes defined in our data model. And the third column is the conclusion of our discussion when there is no corresponding attribute. And for the attribute line upper status, last switching over reason, and so on, these attributes are considered as state data and outer scope of our data model. And temperature, memory, and PCIe are considered as performance and alarm attributes, and which are suggested to be defined in other data model. And for some component type defined in OpenConfig platform are all already considered by our data model, such as fan and controller card. And for some components, we considered that there was no need to manage it from operator's perspective, such as CPU and storage. Okay, next page, please. And for the next step, we think the job is now ready for working group adoption. And we also looking forward to get some input from other technology, such as IP and microwave, to cover more scenario. And we will also continue with our plan to identify some more component-specific attributes and introduce some more component types. And we also progress to fix the remaining issues. If you are interested in our job, and we will warmly welcome you to join the discussion. And we will have a weekly meeting every Wednesday, and you can find more detailed information from GitHub. Thank you.
Thank you. Thanks a lot. And I mean, thanks for including in the next steps the input on IP and microwave technologies. That was something that I was able to raise before we said it. We have Rob.
Sorry, just from finding how to join the queue. So just a quick comment. I think it's great to be trying to align the structure with the open config structure where you can. So I think doing that comparison is really good. The one piece of advice is where you've got the same term and you're choosing a different term. I think that's okay, but I think you've got to have a good reason to do that. So if it's possible to use the same names for things like subcomponents, I would strongly recommend doing that. So the more alignment we can get between the models, the easier it is for people in general.
Yes, agree. Yeah. Thank you.
Okay.
Okay, it's me again.
Yes.
Yeah. Yeah. Okay, this is the first time for this draft to be presented in IETF. This new performance monitoring draft is dealing with traditional performance monitoring on network resource and provides a young data model which can be used in optical network controllers northbound. Next page, please. The motivation of this model is based on these four aspects of consideration. Firstly, as the diagram showing below, we can see that the most of the integration scenario of optical network controller, they have been supported by RASCOM protocol. But for performance monitoring, some traditional protocol are still being used. different protocol usually means different modeling idea, which includes different objects naming and identifiers. The performance monitoring system need to do some adaptation to make it work systemic with the other OSS, so that RESTCOM protocol is also needed in performance monitoring scenario. And secondly, introducing a new protocol does not mean to change everything or existing. Performance monitoring is an important function for the maintenance department, who is very cautious, and operators prefer to inherit the existing performance monitoring function to avoid too many changes to their system to save investment. Currently, for optical technology, performance monitoring are operated on narrow resource, such as monitoring on narrow element, boards, and ports, ODK tunnels, etc. So there's a demand of narrow resource-based performance monitoring young data model. And thirdly, and we analyze the existing performance monitoring data model in IETF. There are no narrow resource basis based. Most of them are based on VPN service or client signal, a virtual network or T-tunnel. They could be the second phase of performance monitoring. The data of this data model can be calculated by the data of our network resource performance monitoring data. They are more abstract and user-oriented. At last, most of the performance monitoring interfaces adopted by operators right now are based on TMF and TOSI. So we choose to specify our data model based on MTOS interface and try to cover all the existing functionality of this protocol. And considering that there are a lot of optical performance indicators, and there could be more indicators in the future. So we propose to specify a generic data model which does not require too many changes to introduce new indicators. Next page, please. We did some research on the TMF MTOSI protocol. The requirement interface defined in TMF MTOSI can be divided into three aspects according to the reference of TMF 518 document delivery package. These three aspects of requirement and interfaces include controlling performance monitoring tasks as per network resource and configuring TCA attributes and TCA notification, and retrieving current or historical performance data and some other performance monitoring related capability. These three aspects of requirement interface should also be supported by our data model in the future. Next page, please. For the controlling of performance monitoring as per network resource, there are three interfaces defined in TMF and TOSI. Includes clear performance monitoring data. This operation could support to clear the performance register for list of measurement points. Disable performance monitoring data. This operation disable the performance data collection for the list of measurement points. Enable performance monitoring data. This operation enable the performance data collection for the list of measurement points. The data model we define is presented on the left. Thirdly, we introduce a PM task concept to do this control. The monitoring on different resource can be specified as different performance monitoring tasks. The ID of performance monitoring task is the identifier of network resource, so that if the client want to clear the data stored in the register of a network resource, it can delete the corresponding task. The second point, yeah.
Sorry to interrupt you. Could you please wrap up in 1 minute because we are a bit late and we still have 2 presentations to go.
Okay.
Thanks. And it would be great also to have to take some questions since we have the opportunity.
Okay. The second point is that we reuse the generic resource identifier from RFC 8632. Okay, and we also introduce a task data which can be used to enable or disable PM data collection. Next page, please. And for the performance monitoring data retrieval, and we choose 2 of them to for research at first, and the other 6 interface will be covered in the later version. And maybe we can take the current data retrieval as an example. We define the separate RPC operation to support this retrieval. The input of these 2 RPC is the identifier of resource, and for historical performance data, the client can also specify the time and the end time. The performance monitoring data output also use a generic structure, which includes indicators name, indicators value, and units of value. Okay, the reason why we don't define the performance data under the performance task data model is based on the consideration that the performance data changes frequently most of the time. So if we take the network scale into consideration, there will be a great amount of data. So that if we define it in the data model, it will be very unstable, and it's better to define it with a on-demand request. Okay, next page, please. And for the next step on this document, we plan to provide we have the following plans. In this version, we have not provided TCA control and notification in the data model. We'll try to cover it in the later version. And we also need to investigate on the other 6 PM data retrieval requests of TMF and TOSI protocol. And for the most important things is we need to invite more people to join this work. So if you are interested in this document, please contact me directly. Next page. Okay, that's all for my presentation today. Thank you. Thank you, everyone.
Okay, we take the question from Robert Dieter and then move on. Please, Rob.
Yeah, I'll try and be quick. So thank you for this. My question is really, is there any overlap with this work with what's going on in IPPM working group? And maybe it's worth presenting there, I don't know. And again, in terms of the name of the module, you've got IETF performance monitoring. Is it very generic to all performance monitoring? Is it more closely, narrowly scoped to something else? And if so, maybe the name of the module should be more narrowly scoped, or if you're looking to do something more generic, then I guess it needs to be worth maybe widening that up. So it's just the scope of the work of my question about.
Okay. And for the overlap with the working group, maybe I can investigate more on the draft mentioned by Robert. Okay, thank you.
Dieter, please. We can't hear you, Dieter.
Okay. Can you hear me now?
Yes.
Yes.
Okay. Sorry. My question is related to the reference in that document. Performance monitoring data is typically provided by the device. And you can enable, disable PM for monitoring points on a device. And all that functionality is described in ITUT recommendation G.7710, right? And moreover, I don't understand why we need an additional PM model. There are already PM models available. You may look on the internet to find PM data models for retrieving PM data for current PM data, as well as for history PM data for 15-minute PM and 24-hour PM data.
Okay. My answer is that the need for the performance monitoring is from the RASCOM protocol level. Is so the performance monitoring could be supported by TMF, which is the traditional protocol, but it is not. It is not the same. It is not a unified protocol with the other scenario. And for the monitoring right now, for this interface is not operated on device. The data model provided in this document is used in the northbound of network controller. Okay.
Yeah, this is another question I have. Why is the function that is shown on that architecture slide not interacting directly with the devices? But anyway, I think we're running out of time.
Yes, please take it to the list, Dieter. We have now Julian for the next presentation.
Yes. Hi again, everyone. This is Julian speaking. Hope you can hear me well. So I'll try to be fast since we're a bit late. Lunch is at stake. So this is an update on the draft that I presented a couple of years ago already. So this is to me the right time to get back to this work, because the technical discussion associated to the use case behind has been well progressed while talking about the young module and the transponder models. So we believe that it's also consistent to bring the associated result of those discussions into the RSVPT signaling. Next slide, please. So reminder on the problem statement we try to address in this ID. Nowadays, on the market, the transponder and transceiver that are sold and deployed on optical networks have multiple ways of working. So those types of working can be referred to as mode, and typical transponder support multiple modes. So this mode needs to be configured, and this configuration need to happen at light up time when we set up an LSP between two endpoints connecting two transponders on the optical line. And one of the major use case behind is the alien use case over an optical line, where there are mainly two operations at stake. Consistent mode configuration at both ends of the light path, and consistent configuration between the mode selected by the optical line and the endpoint on the transceiver sides. So the exception proposed in this document try to address those requirements. Next, please. So quick drawing to summarize the alien use case. So we assume that we have similar transceiver at both ends of the network. Those transceivers are connected to an optical line that may be from a different vendor from the transceiver pair. So the idea here is to convey within the RGPT signaling message, assuming we have a GMPLS control plane running on the optical line up to the transceiver. So the signaling here is supposed to convey the relevant information to request a pass to the line, assuming the optical topology doesn't leak up to the transceiver node, which is out of the optical IGP. On the signaling, request the expected path with the relevant info to let the optical line compute the corresponding path and associated wavelengths, and provide the resulting path and label up to or down to the transceiver at both ends. So using this back and forth LVPT mechanism. Next, please. So in the draft, we propose two approaches which are similar to the encoding that can be found in the optical impairment Young module. One relies on vendor code point space. So in the object carried in the LZPT message, we propose to add a TLV that carries a prefix identifying the vendor and the hardware coding of the transceiver that we are trying to connect to the optical line. And we assume that the line is able to resolve the naming space with a pre-configured table somewhere in the network or in the PCE that allows the optical line to take into account the type of transceiver that is connected, the set of supported mode, the current state of the network in the line, and select an appropriate light path on label to include it into the signaling, as well as a target power to be configured on the emitter at the transceiver level. So there are two kind of fields, two types of fields in the transceiver TLV that we propose. One of them is identifying the hardware, so it's populated before the signaling leaves the transceiver. And the secondary part has prescriptive fields where the optical line is able to add the results of its computation to carry the info down to both transceivers using the signaling flow. Next, please. I'll go faster on this one because this one may deserve more discussion within the working group. But I wanted to clarify that as opposed to what may have been misleading in my previous presentation, the idea in this detailed TLV to be carried in the LGBT message isn't to propose a new optical model to describe a transceiver capability. It aims at being aligned on the existing draft. So I mentioned the optical impairment Young modules. There's also the WDM interface Young module. So the idea here is to be aligned on existing specification, not to propose a new one. So this secondary coding with more detail to be carried in the SOPT probably deserve more work and could be discussed later in the progress of the document. It aims at replacing the previous mechanism that is based on an opaque identifier on a lookup table to resolve the associated optical parameter, and avoid this pre-configuration of this lookup table. But it deserves more discussion to be fully stabilized. So as you may have noticed, it it has changed quite largely between the updates of the draft, and will probably change again in the near future, depending on discussion with the various people I will meet and who suggest some change on those. Next, please. So the main changes, as I said, was to clarify the intent behind the second TLV encoding. There are some details that you may easily identify on spot using the diff online. So let's move to the following slide. Thanks. So the next steps are mainly to keep alignment on existing work in progress in the CCAMP working group. So I already mentioned 2 of the young modules. There is Gabriele draft coming right after my presentation, which is also linked to this document. So global consistency is at stake here. The idea is to keep consistency between all of those works within CCAMP. So the focus here would be to discuss first the simple TLV with the lookup table, and keep maybe the second table, the second TLV for a next step to make sure that the simple one is agreed first. And we believe that considering the companion documents out there, it could be a time to talk about working group adoption. And by the way, I will be on site starting tomorrow. So if anyone wants to bump into me while I'll be in London, feel free to talk about this draft. I'd be happy to answer any question face to face. Thank you. I see Hao-Mian in the queue.
Yes.
Okay. Julian, this is Hao-Mian. Sorry, I'm not in London, so I missed a chance to talk with you face to face. But I do have 2 comments regarding this document. The first one is, yeah, we are open to see the GMPR's extension with impairment parameters, but usually the usage of these parameters are for past commutation and for a kind of maintenance because we have more knowledge. So I see a little bit weird to that this parameters appears in a kind of signaling protocol, which is establishing RSPs. But to me, it would be more proper to have it in the routing or other maintenance-related protocols. And secondly, I read the document and I saw you remove the changing of the modulation from the TR-width, but you mentioned it in your slides again, so I'm not sure about the future plan. But if I remember correctly, it may trace back to our Bangkok discussion, saying that changing the modulation in the optical layer on the fly would be very dangerous because when you for example change from QPS from 16 QAM to QPSK, you lose a lot of bits. So we should be we should be extremely careful on that.
Yes, I agree with you. The idea is not to promote any dynamic quick changes between existing transceivers. It's rather to bring a consistent extension to bring everything on work up and running. I see the clock running. Maybe we can talk about the details offline. Probably I'll leave the mic to the next presenter.
Yes, that would be great.
But I roughly globally agree with you, Hao-Mian. And there are some discussion also. If you want to extend an IGP, I'd be happy to be part of this work, but it's more ambitious and addressing all the use cases using the IGP, maybe a midterm expectation, while we thought that using a simple extension in the signaling could be a first step towards that target.
I'm really sorry to cut you, but we just have 1 minute and one presentation to go. I'm really sorry. Gabriele, your turn.
Can you hear me?
Yes.
Thank you, Daniele, and thank you, Julian, for let's say anticipating some word on this draft. Without changing slides, let me say that this draft just add 2 additional points to what Julian said. The first point is that the optical interfaces may require to implement an SSON, let's say, spectrum, so that we have to change the way we signal from just lambda and so on to a spectrum request. No, that is actually central frequency and width. The second point is that some interface or some request may be on multiple interface or multi-carrier channel, so that in the same media channel you might have more than one carrier or more than one signal. That is another important point, so that in this draft we propose how, or we have implemented actually how to manage multiple carriers inside the media channel, so that any kind of change happenings in the media channel routing is right away reflected to the transceiver. Of course, this draft should be aligned with the Julien draft, with the LNP draft, and last but not least, on all the draft related to the young models describing the same scenario and the same use cases in a centralized control plane solution. I would say that's it. So the next step is, again, align everything. Hope please have a look to the draft, and then please share your feedbacks on the mailing list, and I hope we can go forward doing something good here. Thank you very much. I think okay, we are 1 minute late.
Thanks a lot, Gabriele, and sorry for being so late. Is there any question for Gabriele? Okay, so I think that's it for today. Enjoy the rest of the week, and with CCAMP, see you at IETF115. Thank you, everyone. Bye.
Thank you, Daniele. Thank you, everyone. Bye-bye.
Bye-bye.